Here's an explanation on how to turn two monosaccharides into a disaccharide through dehydration synthesis. To start, two monosaccharides are required. Here I have two glucose monomers, which are monosaccharides that can be joined by a glycosidic bond. In each glucose monomer, you'll notice that there are hydroxyl functional groups, or OHs, as we see here. Since dehydration synthesis involves removing water, we need a hydroxide from one and a hydrogen from the other. Removing these creates a glycosidic bond, a disaccharide, and water. Now, the water is written as HOH and not H2O, but is the same compound. The glycosidic bond can be found between a carbon and an oxygen of the glucose molecules. So that was in regard to carbohydrates, and now we can move on to proteins, which are formed from amino acids, which can make dipeptides through dehydration synthesis. As with the glucose monomers, we'll join these amino acids through dehydration synthesis, which means that once again, we'll need a hydroxide from one amino acid and a hydrogen from the other. And again, through dehydration synthesis, a water molecule is ejected and a bond is formed. This time, however, it's a peptide bond, which creates our final dipeptide. Finally, we can move on to lipids. Today, I'll be building an unsaturated lipid molecule. To do so, I'll need one glycerol molecule, which can be seen on the left, and three unsaturated fatty acid chains, each of which are on the right. You'll notice that, much like the glucose monomers, these molecules have hydroxyl functional groups that will create dehydration synthesis once again. Notice that I'm removing an OH and an H for each bond, respectively, as I did before. After the dehydration synthesis, the water is once again ejected and bonds are formed. However, this time they're ester bonds, which create lipids. In conclusion, disaccharides, dipeptides, and lipid molecules can all be created through the process of dehydration synthesis.